Scientists just looked at Jupiter through the most powerful telescope ever built by human beings. And what they saw has left them completely speechless. Not because it was beautiful, not because it confirmed what they already knew, but because it broke everything they thought they understood about the largest planet in our solar system. The lead scientist on one of the most important Jupiter discoveries of the past decade looked at the data and said, out loud, to his entire team, "This has left us scratching our heads." That is not something scientists say casually. These are people who have spent decades studying this planet, people who have dedicated their careers and their lives to understanding Jupiter, and the James Webb Space Telescope, the most expensive, most sophisticated, most advanced scientific instrument ever launched into space, showed them something they cannot explain. So let me take you through exactly what Webb found, why it is so shocking, and why Jupiter, a planet that has been sitting in our solar system for 4.5 billion years, is somehow still hiding secrets that are rewriting the entire textbook of planetary science. Let us start with the auroras, because this is where things get truly wild. You know what auroras look like on Earth. Those incredible dancing curtains of green and blue and purple light that appear above the Arctic and Antarctica when solar particles slam into our atmosphere. They are breathtaking. They are one of the most beautiful natural phenomena on this entire planet. People travel thousands of miles just to see them. And the auroras on Earth are powered by particles ejected from the sun during solar storms. That is the standard explanation. Particles from the sun hitting the atmosphere near the magnetic poles, creating light. Simple enough. Now, James Webb pointed its infrared cameras at Jupiter's poles, and scientists saw auroras. But these were not anything like Earth's auroras. The auroras flickering across Jupiter's poles produced a dazzling light show that astronomers believe to be hundreds of times brighter than those that occur on Earth, and far more dynamic than previously expected. Hundreds of times brighter. Let that land for a moment. The northern lights on Earth are already one of the most visually overwhelming things a human being can witness in nature. Now imagine something hundreds of times more intense than that, blazing at Jupiter's poles continuously, powered not just by the sun, but by something else entirely. While solar storms contribute to auroras on Jupiter, the giant planet's magnetic field also captures additional charged particles, such as those ejected by volcanoes on its moon Io. These particles get accelerated toward the poles at extreme speeds, then crash into the atmosphere, causing its gases to glow. Io, one of Jupiter's moons, is the most volcanically active body in the entire solar system. It is covered in over 400 active volcanoes, constantly erupting, constantly spewing material into space. And Jupiter's magnetic field is so powerful that it captures all of that volcanic material, accelerates it to incredible speeds, funnels it down toward the planet's poles, and turns it into the most intense auroral display anywhere in the known universe. But here's where it gets truly strange. Researchers analyzed infrared light emitted by a positively charged molecule called the trihydrogen cation, known as H3+, which can form in auroras. They revealed that this molecule's emission fluctuates more than they had previously theorized. The lead scientist, Jonathan Nichols from the University of Leicester, described exactly what his team expected to see when they looked at these auroras. They thought the light would fade in and out slowly, predictably, maybe over 15 minutes or so. What they actually saw was completely different. They observed the whole auroral region fizzing and popping with light, sometimes varying by the second, fizzing and popping by the second. Nobody expected this, nobody predicted this, and nobody can fully explain it yet. The new findings reveal the speed at which auroral emissions change on Jupiter, a discovery that challenges past assumptions and may potentially reshape the ways scientists understand the interactions that occur in the Jovian atmosphere and in the space surrounding it. This is not a minor adjustment to existing theory. This is a fundamental challenge to how scientists model the relationship between Jupiter's magnetic field, its atmosphere, and the space around it. But the auroras are just the beginning, because Webb did not stop there. Scientists aimed the telescope at something even more iconic, something that has been staring back at humanity from the night sky for centuries. The Great Red Spot, the largest storm in the solar system, a hurricane so enormous it has been raging continuously for at least 350 years, possibly longer. A storm so massive and so powerful that the entire planet Earth could fit inside it. And Webb found things inside and above this storm that simply should not be there. Scientists observed the region above Jupiter's iconic Great Red Spot using the James Webb Space Telescope and discovered a variety of previously unseen features. The region, previously believed to be unremarkable in nature, hosts a variety of intricate structures and activity. Before Webb looked at this region, scientists expected to find essentially nothing interesting. They thought the upper atmosphere above the Great Red Spot would be quiet, uniform, boring. The storm is down in the clouds, they said. The upper atmosphere above it would be mostly undisturbed. Webb proved them completely wrong. Astronomers found previously unseen structures and activity in Jupiter's atmosphere above the Great Red Spot. These odd features seem to be caused by powerful atmospheric gravity waves, dark arcs, bright spots, intricate patterns spread across an area of sky bigger than our entire planet. None of this was predicted. None of this was expected. And the explanation that scientists are working with right now involves something called gravity waves, which are not gravitational waves in the Einstein sense, but waves of pressure and density moving through the atmosphere, similar to ripples in water. Except the scale of these waves on Jupiter dwarfs anything ever recorded on Earth by an enormous margin. And then Webb found something else, something completely new, something that had never been seen before in the history of Jupiter observation. NASA's James Webb Space Telescope discovered a new, never-before-seen feature in Jupiter's atmosphere. The high-speed jet stream, which spans more than 3,000 miles wide, sits over Jupiter's equator above the main cloud decks, a jet stream, more than 3,000 miles wide, sitting above the equator at speeds that make the most powerful winds on Earth look like a gentle breeze. This jet stream was invisible to every telescope that had ever looked at Jupiter before Webb. It was hidden. And now that we know it is there, scientists are trying to understand what it does, how it interacts with the storms below it, and whether it has been there for centuries, or whether it is something relatively new. We do not know. And not knowing something this enormous about a planet this close to us, a planet that has been studied intensively for over 400 years since Galileo first pointed his telescope at it, is genuinely shocking. Now let us talk about what is happening to the Great Red Spot itself, because this is where the story gets both fascinating and deeply mysterious. Jupiter's Great Red Spot has shrunk to a diameter of 10,250 miles, the smallest measurement ever recorded. According to data from NASA's Hubble Space Telescope, this storm was once as large as 25,500 miles across. Think about those numbers for a moment. This storm used to be 25,000 miles across. That is large enough that you could fit 3 planet Earths inside it, side by side, and still have room. And now it has shrunk to 10,000 miles. It has lost more than half its size. And not only is it shrinking overall, it is doing something bizarre in the process. It is shrinking and growing and shrinking again, almost like it is breathing, pulsating, contracting and expanding in ways that do not follow any neat, predictable pattern. A study from Yale University used 3D simulations of interactions between the Great Red Spot and smaller storms, and found that nearby storms would strengthen the Great Red Spot by increasing its size. So the current shrinking of the spot may be due to a lack of smaller storms in its diet. The Great Red Spot feeds on smaller storms. When a smaller anticyclone wanders too close to the Great Red Spot, it gets absorbed, merges into the larger storm, adds to its energy, keeps it going. But right now, there appear to be fewer of these smaller storms available for the Great Red Spot to consume. And without that food supply, the greatest storm in the solar system is slowly starving. Recent data from NASA's Juno mission have shown that the Great Red Spot is much shallower than previously thought, extending only about 500 kilometers deep into the atmosphere, compared to its vast horizontal dimensions. For decades, scientists assumed the storm went incredibly deep into Jupiter's atmosphere, thousands of kilometers down. Juno showed us that the actual storm structure is only about 500 kilometers deep, which is still deeper than all of Earth's oceans combined, roughly 50 times over. But by Jupiter standards, that is surprisingly shallow. The roots of this centuries-old storm do not reach nearly as far into the planet as everyone thought, and pieces of it are breaking off. In 2017, telescopes spotted a hook-shaped cloud detaching from the western side of the storm. Red flakes, chunks of the Great Red Spot itself, flying away into the surrounding atmosphere. Some of these chunks are enormous, hundreds of thousands of kilometers in size, bigger than some entire countries on Earth. And according to computer models, this is a result of the storm colliding and interacting with smaller cyclones that spin in the opposite direction. When an anticyclone meets a cyclone, they do not merge. They repel each other violently, scattering in different directions and tearing pieces off the edges of the larger storm in the process. This is what is slowly dismantling the Great Red Spot, a combination of reduced feeding from smaller storms and violent interactions with oppositely rotating cyclones that chip away at its edges. Scientists project that if the current trend continues, the Great Red Spot could disappear entirely within approximately 20 years. Now, nobody is entirely certain of this. Jupiter has surprised everyone before. Wind speeds around the outer edge of the Great Red Spot have actually increased by 8% between 2009 and 2020, suggesting the storm still has enormous energy even as it shrinks in size. It is possible the storm stabilizes at a smaller size. It is possible a new storm emerges to replace it. In the year 2000, three smaller white oval storms on Jupiter merged together. By late 2005, that merged storm had turned red. Astronomers called it the Little Red Spot, or Red Spot Junior. It was a completely new storm, born from the merger of older ones, turning red before their eyes. Jupiter's atmosphere creates and destroys storms on timescales that dwarf human civilization. But the Great Red Spot has been continuous and dominant for hundreds of years. If it disappears, then something fundamental about Jupiter's atmospheric dynamics will have changed. And we have no idea what that will mean for the planet overall. Let us go deeper into what Webb has shown us about Jupiter's moons, because the discoveries there are just as extraordinary and carry implications that go far beyond astronomy. High-resolution infrared images of Jupiter from the James Webb Space Telescope reveal differences between high-floating bright clouds, including the Great Red Spot, and low-lying dark clouds. Also clearly visible in the featured Webb image are Jupiter's dust ring, bright auroras at the poles, and Jupiter's moons Amalthea and Adrastea. The footprint of large volcanic moon Io's magnetic funneling of charged particles onto Jupiter is also visible in the southern aurora, in a single image, one image from Webb showing Jupiter in infrared light. Scientists can see the ring, the auroras, two moons, and the actual magnetic footprint of Io's connection to Jupiter's atmosphere, visible as a glowing signature in the southern lights. The level of detail that Webb provides is not just incrementally better than what came before. It is a completely different order of magnitude of clarity. And Ganymede, Jupiter's largest moon, the biggest moon in the entire solar system, larger even than the planet Mercury, has been revealing secrets of its own. Scientists have found evidence that this moon was struck by an asteroid nearly 93 miles wide, approximately 4 billion years ago. An impact so powerful it knocked Ganymede off its axis and altered its rotation. The same moon that now shows water vapor in its thin atmosphere. And beneath its frozen surface, scientists believe there may be a vast ocean of liquid water buried under the ice. If that ocean exists, and the evidence is increasingly suggesting that it does, it represents one of the most significant potential locations for life beyond Earth anywhere we know of in this solar system. Not on the surface, which is barren and frozen, but deep underneath, in liquid water warmed by geological processes, shielded from radiation by kilometers of ice. Europa, another of Jupiter's moons, has similar characteristics, and a series of experiments support spectral data recently collected by the James Webb Space Telescope that found evidence that the icy surface of Jupiter's moon Europa is constantly changing. Europa's surface ice is crystallizing at different rates in different regions, a surface that is actively changing, which implies processes underneath that are actively happening, which implies liquid water, which implies the possibility of chemistry, which implies the possibility of life. Now, let us talk about something that almost nobody outside of planetary science knows about, but that fundamentally changes how we think about Jupiter's role in our own existence. Jupiter has long been called the solar system's guardian, the shield. The idea was that Jupiter's enormous gravitational field sits out there in the outer solar system and catches comets and asteroids before they can reach Earth, swallows them up, deflects them, protects the inner solar system. And there is truth to this. In 1994, the comet Shoemaker-Levy 9 broke into pieces and slammed into Jupiter in a sequence of impacts that, had they hit Earth instead, would have caused a mass extinction event. Jupiter took the hit, so Earth did not have to. But the newer picture is more complicated and more unsettling. Jupiter's gravity does not just protect us, it also redirects things toward us. The gravitational resonances created by Jupiter's mass interact with the asteroid belt between Mars and Jupiter, nudging asteroids out of stable orbits and sending some of them on paths that cross Earth's orbit. The same force that protects us from long-period comets incoming from the outer solar system can simultaneously serve as a gravitational pinball machine that launches shorter-period asteroids inward toward Earth. Jupiter is simultaneously our shield and one of our sources of danger. And if anything were to change about Jupiter, if its orbit shifted, if its mass distribution changed, the consequences for Earth's long-term stability could be profound. And something is happening to Jupiter's core that is rewriting the textbooks on how gas giant planets are formed and what they are made of. For most of scientific history, the standard model said Jupiter has a dense rocky core at its center, surrounded by layers of compressed gases. Simple, elegant, widely accepted. Then Juno started measuring Jupiter's gravitational field in extraordinary detail during its dozens of close flybys, and the data came back completely wrong. Jupiter's core is not compact and dense, it is diffuse, spread out, extended. Deep within Jupiter's inner regions, only 18% of the material is actually rocky. The rest is mixed into a fuzzy, extended region that transitions gradually from the metallic hydrogen outer layers rather than having a sharp, distinct boundary. Scientists call it a dilute core, and it suggests that Jupiter may have been hit by a massive protoplanet early in the solar system's history, an impact that shattered the original compact core and spread its material outward. An enormous collision billions of years ago that scrambled Jupiter's interior into the diffuse structure we are only now beginning to measure. And speaking of metallic hydrogen, let us spend a moment on this because it is one of the strangest materials in the universe. As you go deeper into Jupiter, the pressure increases to levels that do not exist anywhere naturally on Earth. Under these conditions, hydrogen, the simplest element in the universe, the same gas that makes up most of our sun, undergoes a transformation. It becomes liquid metallic hydrogen, a substance that conducts electricity like a metal, flows like a liquid, and exists under pressures and temperatures that no laboratory on Earth has ever fully replicated. It is a state of matter that we understand theoretically but have never directly observed, and Jupiter is essentially made of it. Thousands of kilometers deep, an ocean of liquid metallic hydrogen generating electrical currents that create Jupiter's magnetic field, the largest magnetic field of any planet in the solar system. A magnetic field so vast it extends 725 million kilometers into space. If you could somehow see it, Jupiter's magnetic field would appear larger in our sky than the full moon does. And inside this magnetic field, scientists have identified something they call the Great Blue Spot. Not a storm, not a visible feature, but a concentrated region of intense magnetic field south of Jupiter's equator. The Jovian magnetic field overall is already 20,000 times stronger than Earth's. But the Great Blue Spot is a concentration within that, a region where the magnetic field is especially intense and where it is changing, strengthening and weakening by up to 1% per year in different regions. A planet-sized magnetic structure that is actively evolving. The Great Blue Spot sits at roughly the same latitude as the Great Red Spot, and scientists have begun to wonder whether these two phenomena, one a storm visible in the clouds and one a structure in the magnetic field far below, might somehow be connected. Whether the storm in the atmosphere and the magnetic anomaly beneath it are two expressions of the same underlying process. Nobody knows the answer yet. And here is the final piece of the Jupiter puzzle that should make every person watching this truly pause and think. A new model published in January 2026 is finally peeling back Jupiter's clouds, with researchers finding the planet likely holds significantly more oxygen than previously estimated. More oxygen than anyone expected, locked up inside Jupiter in the form of water and other compounds, hidden in quantities that our previous measurements dramatically underestimated. Oxygen in abundance inside the largest planet in our solar system. And we are only now, in 2026, beginning to understand just how much is there. Because every time we get a better instrument, every time we build a more powerful telescope or send a more capable spacecraft, Jupiter reveals something that overturns what we thought we knew. This is the planet that does not orbit the sun the way every other planet does. The center of gravity between Jupiter and the sun does not sit inside the sun. It sits just above the sun's surface, which means that technically, Jupiter and the sun orbit each other around a shared point in space. Jupiter is so massive that it makes the sun wobble, and it has been sitting out there in our solar system, making the sun wobble, shaping the asteroid belt, capturing moons, generating the most powerful auroras in the known solar system, hiding a diffuse, shattered core, generating an ocean of metallic hydrogen, and throwing enormous, unexplained jet streams into its own upper atmosphere for 4.5 billion years, long before life existed on Earth, long before Earth itself was fully formed. And we are only now, with the James Webb Space Telescope, finally getting close enough in terms of observational power to start seeing what is actually happening there. Every new image from Webb changes the picture. Every new discovery raises more questions than it answers. The scientists who said this has left us scratching our heads were not expressing frustration. They were expressing the most honest feeling in all of science. The feeling of standing at the edge of what humanity knows, looking out into the unknown, and realizing that the unknown is so much larger, so much stranger, and so much more magnificent than anything we had previously imagined. Jupiter is not just the biggest planet in our solar system, it is one of the greatest unsolved mysteries in the universe. And the James Webb Space Telescope has only just begun to show us what we do not know.